Hello everyone. In this video, we will discuss about lithium chloride and lithium carbonate, which are the compounds of elements of S block elements. And before discuss to the preparation properties of lithium chloride and what are the various applications of lithium chloride and lithium carbonate, let us discuss. We will also discuss some properties and characteristics of the S and P block elements. In this slide, we will discuss about the position of S and B blocks elements in the modern periodic table. As we can see that yellow highlighted columns, these are the first column, second column, third, fourth, fifth, sixth, seventh, eighth, ninth, 10, 11, 12, this 13, 14, 15, 16, 17, 18. Out of these 18 columns, these first two columns refers to as first and second groups, which is mainly consists of S block elements. And out of these, in this case, we can see this block which is shown in the blue color. It represents the D block elements in case of modern periodic table, which is from 3rd to 12 groups. And this is the shown in the light purple color. This is from 14 to 18 groups. These are mainly referred to as P block elements, which mainly consist of metal, metalloids, and non-metals in P block groups. And in the last two rows, that is in the this one lanthanum, starting from actinium, they mainly refer to as lanthanide series and actinide series, and these are also referred to as F block elements. And why they are located at the bottom? Because they are mainly position is in the sixth and seventh period. These are the out of seven periods, they are existing in the sixth period and seventh period. But due to the shortage of space in that case, it is placed out of the modern periodic table. That's why they are also referred to as inner transition elements, because in case of D block element, they are referred to as transition elements. In this slide, we will discuss about S block elements, where they are positioned in the modern periodic table, what elements are present in S block elements, which is mainly existing in case of first group and second group, and what are the other properties of S block elements. We can see that the S block elements, as we have discussed in the earlier slide, that in periodic table, the first two groups, that is first group and second group, these are also referred to as alkali metals for first group, and second group is referred to as alkaline earth metals, and along with the hydrogen and helium, which is also present in case of first and this one group. And the group first A of periodic table, it consists of elements we have like lithium, we have sodium, that is Na, potassium, that is K, rubidium, Rb, cesium, and francium. These are the elements which are existing in case of group first A, and these are collectively known as alkali metals. And these are also called, why they are called alkali metals? Because they can easily form the hydroxides on reaction with water, when we can say that they are strongly alkaline. As we can say that when Na metal is reacting with the water, it is producing the NaOH, which is strongly alkali in nature. Similarly, if we are reacting with the potassium with HOH, then that is also producing the KOH, that is also having very strong alkaline nature. So we can say that they are alkali metals. Similarly, if we are discussing about group second, they consist of elements like beryllium, magnesium, calcium, strontium, barium, and radium, which are represented by symbol Be, Mg, calcium, Sr, Bara, and these are also collectively known as alkaline earth metals except beryllium. These are also called, why they are called alkaline earth metals? Because their oxides and hydroxides are alkaline in nature, and these metal oxides are also found in case of earth crust. So that's why they are referred to as alkaline earth metals, because their oxides and hydroxides are alkaline in nature and they are existing in earth crust. That's why we are calling them alkaline earth metals. In S block elements, the last electron, it enters in the outermost s orbital, and because we know that s orbitals can exist maximum number of electrons is 2. That's why only two groups, that is first and second group, belong to the S block groups of the periodic tables. In this slide, we will discuss about some properties, elements, electronic configuration of S-block element, which is also referred to as alkali metal. As we can say that in the first group, which is of S-block elements, in the first group we have hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, which includes the elements but not H mainly in this case. So basically, these are all from lithium to francium, and in this case last electron filled in the s orbital, and it is having the electronic configuration last s1. For example, we can say that lithium has atomic number 3. If we are writing the electronic configuration of lithium, it can be written as 1s2 2s1. Similarly, if we are taking the sodium, that is 11 atomic number, we can write the electron configuration 1s2 2s2 2p6 3s1. As we can see that last electrons enter in the s orbital, or it only having one electron in the last orbital. That's why they belong to the first group of the s block elements in modern periodic table. These metals are soft in nature, that can be easily cut by knife, and they are highly reactive in nature. That's why they are not found in the nature as free elements, but they are always existing in form of some compounds like NaCl, KCl, etc. And they are highly reactive. They can easily react with the air and water, and they react strongly with the halogen compounds, and they can prepare salts like NaCl, KCl, cesium chloride, etc. Now, in this slide, we will discuss about the S block elements, group 2 elements, which are also referred to as alkaline earth metals. As we can see, we have following elements existing in case of group 2, that is we have beryllium, magnesium, calcium, strontium, barium, radium. These are the elements which exist in case of alkaline earth metals groups, that is of group 2 of S block in periodic table. They ends with the S2 configuration. As we can see, we have beryllium has 4 atomic number, magnesium have 12 atomic number. If we are writing the electronic configuration of these elements, we will see that for magnesium we have 1s2, 2s2, 2p6, 3s2. So here last s orbital is filled by 2 electrons. Similarly, if we are discussing about calcium, we have 20 atomic number. When after writing the electron configuration in the last shell we have, that is 4s2 is the last shell in case of calcium, because others we have shown by calcium. So in this case we can also see that 4s orbital is also possesses 2 electrons. That means they exist in case of group 2, that is the alkaline earth metals. And these alkaline earth metals are stronger, denser, harder than the alkali metal, that is of group 1 element. They are also reactive in nature, and it can be also found as free elements, and they are also found in the case of compounds like calcium carbonate, that is called as limestone. Now let us discuss some important characteristics properties of elements that exist in the S block group of modern periodic table. First, we will discuss about electronic configuration. So we can see that general electronic configuration of S block elements is an S1 for the alkali metals, that is in case of group 1 elements, and NS2 for alkaline earth metals, that comes into the group 2, where N can be numeric value can be 2 to 7 for NS1 and NS2. Similarly, all the alkali metals and alkyl earth metals are mostly electropositive metals because they can easily lose one or two electrons to obtain the nearby noble gas element novel electronic configuration, because we know that noble gas are the stable electronic configuration. That's why they want, we know that every element has a tendency to get the stable electronic configuration as similar to noble gas. That's why they can easily release the one or two electrons. So they are most electropositive metals in the periodic table. If we discuss about metallic character of these elements, all the alkali metals are very silvery white, soft and light metals, and also alkaline earth metals are also silvery white, lustrous and relatively soft, but they are harder than the alkali metals. If we discuss about atomic density of these elements, then we found that alkali metals and alkaline metals, that is alkaline earth metals, both have low density. Why this is? Because they have large ionic size due to their atomic nuclei, and they are widely separated in the crystal lattice. That's why they have very low density. And the density, it increases when we are moving from top to bottom in both the groups. That's why we can say that density is increases because size is also increases. Now let us discuss few more important characteristic properties of elements that exist in S block in case of modern periodic table. If we are discussing about melting point and boiling points of these elements which are existing in S block, then we will find that both melting point and boiling points of alkali metals are low, and the melting point and boiling points of alkaline earth metals are higher than the corresponding alkali metals due to their small size. As we can see this graph, this represents the behavior of melting point and boiling point of alkali metals and alkaline earth metals. This pink color line represents the boiling point of different alkali metals and alkaline earth metals, or while this blue line, it represents the melting point of curve of alkali and alkyl earth metals in case of group 1 and group 2 elements. So we can see the trends that all the they have very line, and we are men who are moving in this one, so that is increasing if we are moving from top to bottom. If we discuss about oxidation state, then alkali metal shows only plus one state, while alkaline earth metal shows plus two oxidation state, as we have discussed in the earlier slide, because they are highly electropositive metals. Because in group 1 we have only one electron present in s orbital, that's why they can release plus one electron, so they are having the plus one oxidation state. But in case of alkaline earth metals, we have two electrons present in the s group, s elements. That's why they can make the plus two oxidation state only. And if we will discuss about atomic and ionic radii of this one, then we found that both the alkali metals and the alkaline earth metals, the atomic radii and ionic radii increases if we move down from top to down in the both the groups. These are the pattern which shows for both atomic and ionic. This blue color line shows the atomic radii, and this pink color line shows the ionic radii in both. So this represents for this one, and this is for this one. So we can say that this is for group 1 elements like we have lithium, sodium, potassium, etc. And this is for the second group, that is also referred to as alkaline. So we can see clearly seen that if we are moving from top to bottom in the group, this continuously atomic and ionic radii is increasing. Similarly, in this case, group 2, that we can also similar pattern can be observed that they are increasing if we are moving from top to bottom in the group. Now, these are few more important properties of elements in S block, that is electrode potential. Alkali metals are strong reducing agents, and the standard electrode potential of alkali metals lie in between minus 2.7 volt to minus 3 volt, which indicates a strong tendency to form cation in solution. While the alkaline earth metals, they have negative values of their standard electrode potential. Similarly, if we are discussing about ionization energy, what is ionization energy? It is the energy required to remove an electron in the gaseous state from an element, that is called as ionization energy. So if we will see that ionization energy of alkali metals are considerably low and decreases down the group from lithium to cesium, as we can see in this case, that is continuously decreasing in the group in this case. Similarly, the alkaline earth metals also have low ionization energy due to the large size of the atom, as we can see in the pink color, which represents the group 2 elements. Blue color line shows represent the group 1 elements. So it is continuously decreasing because size is also increasing. So due to the increase in size, the ionization energy of these two groups, that is continuously decreasing, because holding of nucleus on that electron, it will be reduced. That 5 electron can be easily released from this one. Now come to the p block elements. In p block elements, we have three types of categories, as we have discussed in the earlier in the modern periodic table chart. that we have three categories: metals, non-metals, metalloids. And in the p block elements, the last electron enters in the np orbital, which includes six groups that starts from the group 13 to 18, that is called as boron, carbon, nicogen, chalcogens, halogens, and noble gas families. And the valency shell electron configuration for these block elements in general is, that is, ns2 np126, except for helium, because in that case we don't have any p orbital. And the heaviest element in the entire p block is mostly metallic nature. Non-metallic character of element also decreases if we are moving from top to down in the group. Similarly, this is the electronic configuration of chlorine. We can see that last electron enters in the P. As we have shown here, we have general configuration NS2 and P126. In this case, we can see that we have 5 number electrons present in case of chlorine atom. If we discuss about p block elements, then we will find that there is a difference in the inner core of elements which greatly influences their physical properties like atomic, ionic radii, ionization enthalpy, as well as chemical property also. And non-metals also having ionization enthalpy and electronegativity than the metals. Hence, we can say that metals can easily form cation while non-metals can form anions. As we know that tendency that they can easily accept electrons, that's why they are forming anions, or metals can easily release the electron, that they can easily form the cation. And the compound formed between non-metals are mainly consist of covalent bond types nature, while the compound which is mainly formed between the metal and non-metals, they are of type ionic bond, that we can say that they are having type of ionic compound. Yeah, we can say that electrovalent compound, like we have NaCl. Na is metal while Cl is the non-metal in nature. Now let us discuss some important properties of p block elements, like we have electronic configuration, metallic correction, metallic characters. What are the trends we are finding in case of this one? So this, in this case of electronic configuration, we are finding that in different groups, that is group 13 to 18, electron field, that configuration is ns2p12, ns2p6, as we have discussed in the earlier slide, except helium. If we are discussing this chart, this yellow color blocks that represents the metal in case of P block, and this green color which is in the form of zigzag pattern, they refer to the metallites. Metallites are having property between metals and non-metal, and these pink color elements shows the non-metallic elements in case of P block elements. So these are mainly non-metallic. If we discuss about metallic character, the non-metallic character, it decreases continuously from down the group, and while if we discuss about metallic character, it tends to increase down if we are moving in the group, because, or left, if we are moving from left to right, then it decreases. Now let us discuss some more properties of elements which comes into the p block in the modern periodic table. Like we have oxidation state, we have atomic and ionic radii, we have electrode potential. So we can see that the p block elements, they show variable oxidation states, and the oxidation states increases as if we are moving from left to right in the periodic table. And these are the different variable oxidation state which is shown by the different families which are come into the different groups of p block elements. Like for boron family, we change it mainly show +1 and +3. Similarly for carbon family, we can say that they show +4, +2, -4, and similarly the other groups show different variable oxidation state in different groups. Similarly, if we will discuss about atomic and ionic radii, then we will find the pattern that atomic and ionic radii, that increases down the group if we are moving from top to bottom in the group due to the size increases. And if we move from left to right in a period, then we will find that atomic and ionic radii of p block element decreases as EAN value is also increases. Similarly, electrode potential, they have positive electrode potential, and it generally decreases if we are moving from top to bottom in the group, as we can see in this case that fluorine, chlorine, bromine, iodine, this is from the top to bottom. We can see that value is continuously decreasing in this case. Now come to the compound of element of group 1, that is lithium. So we have two important compounds of lithium, that is lithium chloride and lithium carbonate, that we will discuss on the later on slides. So what is lithium chloride? Basically lithium chloride is a chemical compound which is having the formula that is LiCl, and it is how it is formed. As we can see in this one, that lithium has configuration 1s to 2s1. That red color spot represents the electron present in the s orbital, and while in case of Cl we have 7 electrons in the valence shell orbital. That's why one electron from Cl and one electron from lithium, they overlap with each other, and after that they are forming the LiCl compound. And it looks like a salt because it is the ionic in nature. As we know that lithium is the electropositive and chlorine is the electronegative element, so they can form easily the ionic type of compound which has good solubility in the polar solvents. And they are hygroscopic nature, they can easily absorb the moisture. Color is white, appearance is crystalline solid, melting point of lithium chloride is 605 degrees centigrade. This is the cubic type structure of lithium chloride, in which yellow color atom represents the lithium ions and green color atom represents the Cl minus atoms in case of lithium chloride cubic structure. Now let us discuss preparation methods of lithium chloride, how we can prepare lithium chloride. First method is that we can discuss that lithium chloride is produced by the treatment of lithium carbonate along with the hydrochloric acid. When we are reacting with both, then we are getting the lithium chloride salt. Second method is that it can also be generated by highly exothermic reaction between the lithium solid and chlorine gas. On reacting, it will produce the LiCl crystalline solid, which is of white type solid. Another method is that when lithium chloride is react, it can be obtained by reacting with the aqueous lithium hydroxide along with the hydrochloric acid. Then it will give the LiCl aqueous solution of lithium chloride. Another method is that it can be also be obtained by thermal decomposition of lithium perchlorate solid. When we are heating lithium perchlorate solution, then we are getting the lithium chloride salt in solid form. These are some of the physical properties of LiCl, that is lithium chloride. It is hygroscopic in nature, that can be easily absorb moisture on contact with the air. It is white crystalline solid, odorless. Melting point is, that is 605 degrees centigrade. Boiling point is 100, 300, 1382 degrees centigrade. Molar mass is 42.394 gram per mole. Density this one. It is highly soluble in alcohol and water, and electrical conductivity is high due to its ionic state in solution form, because when it will dissolve in the aqueous solution, it can be dissociated into the lithium ion and chloride. That's why it is highly conductive in nature. These are the chemical properties of lithium chloride. If we will discuss about stability, we will find that is stable under ordinary condition of use and storage, and these are very hazardous decomposition products. It emits toxic fumes of chlorine when heated to decomposition. pH of lithium chloride, it is mainly neutral or slightly alkaline in nature. It is highly ionized in solution form, as we will dissolve in the solution form in water, that it will be dissociated into lithium and chlorine ions. So we can say that it is highly ionized because it is the ionic compound. Similarly, lithium chloride forms crystalline monoprene pentahydrates, monochlinic hydrates to give LiOH and HCl, and this is the lithium chloride. When it is reacting with the silver nitride, it will give the white PPT of AgCl. Now let us discuss some applications of lithium chloride in different areas. We can use lithium chloride metal for production purpose by electrolysis method. In various applications, lithium chloride find some uses in organic synthesis, like as an additive in the steel reaction, as we can see in this one. This steel reaction is utilized mainly for coupling of two different groups. It can also be used to precipitate RNA from the cellular extract in the biochemical application purpose. It can also be utilized as a flame colorant, as we can see this one. On mixing it will produce the dark red flames. It can also utilize as a desiccant for drying streams. It can be a relative humidity standards in calibration hygroscopometer. It can be also utilized as a basing flux from aluminium in the automobile parts. These are some of the potential health effects which is caused by the ingestion या inhalation या that can be produced by on swelling inside our body by lithium chloride. It can have attack our central nervous system. It can also affect our respiratory system. It can also affect the muscles and kidneys of our body. It can cause severe irritation to skin, eyes, and respiratory tract, and other symptoms like slurred vision, slurred speech, blurred vision, heart and brain effects. Now let us discuss about lithium carbonate, which is also another important compound of lithium elements of S block element, which comes into group 1. Lithium carbonate is an inorganic compound which is having formula Li₂CO3. It is having colorless, odorless, crystalline solid in physical appearance, and it is also insoluble in different organic solvents, having poor solubility in water, which is mainly decreases if we are increasing the temperature. Solubility increases in presence of other alkali metals or ammonium salts, excluding carbonates only. It decomposes below the boiling point, that is 1310 degrees centigrade. Melting point of lithium carbonate, it's having value 720 degrees centigrade. It is having monoclinic type of structure in which it is these are the lithium and carbon oxygen atoms are representing in this case. Now let us discuss some preparation methods of lithium carbonate. Lithium carbonate can be manufactured by reacting with lithium sulfate along with the sodium carbonate. Then we are getting the lithium carbonate. Similarly, it can also be generated by combining lithium peroxide with the carbon dioxide. On reaction with this one, we will also get the lithium carbonate. Now let us discuss some chemical properties of lithium carbonate. It can be suspended in water, then it can react with the carbon dioxide and H2O, then it can produce the lithium hydrocarbonate, which increases its solubility around tenfold. We will discuss about another property of lithium carbonate. It can react with the minerals and carboxylic acid, like in this case we have reaction with the hydrochloric acid, then it is producing the lithium chloride as we have discussed in the preparation of lithium chloride. On heating the mixture of lithium carbonate along with the magnesium, it will produce the lithium peroxides and we can see lithium oxides. Similarly, it also reacts with the caustic soda, that is LiOH, and it will produce the lithium hydroxide on reactive with the caustic soda. These are some of the important applications of lithium carbonate. It can be utilized as a source reagent for other lithium compound synthesis for the production of ceramics like litol, electric insulated porcelains, in the manufacturing of heat resistant ceramics coating in combustion and nozzles of jet engines. It can also be utilized as a component of glazes, enamels, acid resistant coatings for aluminum, cast iron, sheet steel. It can also be utilized as a gas glass additive. It can also be utilized as a flux in the aluminum manufacturing industry, which can be utilized for soldering purpose. It can be utilized as a flux for soldering of aluminum magnesium. It can be also utilized in the fuel cell and as an additive in the cement industry, etc. These are some of the practice questions based on the present video that we can give the answers. What are lithium chloride and lithium carbonates? We can also write the preparation of lithium chloride, write preparation of lithium carbonates, and these are some of the practical questions that can be solved on the basis of this present video. These are some of the references that will be helpful for preparing this video. At last, thank you for your paying attention.